In this first video, in a series of indices laws, we are going to be looking at multiplying and dividing numbers that are written in index form. Now, index form is a number that's written like this, a to the power b. So for example, 3 squared, which means 3 times 3, 4 cubed, which is 4 times 4 times 4, and so on and so forth. You have the base, which is letter A, and you have B, which is the power. Now, these laws only work when the base, that's the letter A, is the same. The first one we're going to look at is multiplying. Let's say we have 3 squared times 3 to the power 4. What we want to be able to do is simplify it and write it as a single power and work out what that x is. 3 squared is 3 times 3. 3 to the power 4 is 4 lots of the 3's, all multiplied together. Now, if you count them, you're 1, 2, 3, 4, 5, 6. So I could write this as 3 to the power 6. Notice I have a 2 and a 4, and it gave me a 6. And that's the rule. A to the power m times a to the power n is a to the power m plus n. When you're multiplying, you add the powers. But be careful, this is only true when you have the bases the same. So for example, if you have 2 cubed times 3 to the power 5, a really common mistake is to do 2 times 3, which is 6, and then 3 plus 5, which is 8. That is incorrect. And actually, there's not really very much you can do here. That's the final answer. Let's have another example where the bases are the same. Let's say we had 3 squared times 3 cubed times 3 to the power 4 times 2 squared. Well, I can look at the bits that have the 3's as the base and just forget about the 2's. So the 2 squared is just going to stay. We can't do anything. But I can add the powers together as long as the bases are the same. 2 plus 3 plus 4 is 9. So I can write this as 3 to the power 9. And that'll be my final answer. So just remember, when you're multiplying powers, you add them as long as the bases are the same. If the bases aren't the same, you can't do anything. And exactly the same thing is going to happen when we're dividing. Other than adding, when we're adding, we're now going to be subtracting. 4 to the power 5 divided by 4 to the power 2. Now, for proof that we're going to be subtracting, let's just write it out. We've got 5 lots of 4 on the top, and we've got 2 lots of 4 on the bottom. And what happens is that the 2 on the bottom cancel with the 2 on the top. And I'm just left with 3 4's on the top, 4 cubed. I can do 5, take away 2, and that would give me the 3. So the second law is that a to the m divided by a to the n is a to the m minus n. Let's have one more example. Let's say we do 3 to the power 5 divided by 3 to the minus 3. Now, a really common mistake here, and you've got to be really careful with this, is that students go, 5 take away 3, awesome, that's 3 squared. But that is incorrect. You don't do that. We do 3 to the 5 minus negative 3. The 2 minuses make a plus, so it's actually 3 to the 5 plus 3, which is 3 to the power 8. Let's combine these two rules together. Let's say we have 2 to the 4 times 2 to the 3 divided by 2 to the 2 times 2 to the 10. Well, let's start with the numerators, and we're going to add the powers. 4 plus 3 is 7, so we have 2 to the power 7. And same on the denominator, we have 2 to the power 12. Now we're dividing, we subtract the powers. 7 minus 12 is minus 5, so I get 2 to the power minus 5. And there we have it. That's how you multiply numbers in index form. We add the powers. And that's how we divide numbers in index form. We subtract the powers.